The whole formation was tilted uniformly. It is proposed that such tilting is due to the subsidence of the base of the caldera.
You can see that the columns here are not only tilted slightly, but also bent and curved. Do you know how that could happen?
It is possibly related to the state of rocks when they were cooling. Just imagine, if you have some biscuit sticks and they tilt, what will happen?
I think nothing's happening at all.
What I want to say is, they will be as straight as they were, just like the straight columns. They were rigid when they were tilted. But then, if we have some long chewy candies, when they tilt, they will not only rotate, but they will also change in shape, just like the banded columns. We call this process ductile deformation.
So, for this situation, the temperature of the rock was still high when it deformed. The ash deposition was then only partially solidified, so they bent like the chewy candies.
Here we can see something different at the center of the buckling section.
The dark gray intrusion cuts through the columns. We call it a mafic dike. As the polygonal columns creep down along the tilted floor, they formed banding. But due to excessive twisting, the columns are sometimes broken in the middle.
When the volcanic ash was completely solidified, the magma from below intruded this weaker part, which was probably the fissure formed during bending. The magma cooled down and formed the dark gray dike.
We can easily distinguish the two kinds of rocks by their distinctive light and dark colors. Felsic rocks are light, mafic rocks are dark. So here, the columns are felsic and the dike is mafic.